Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter relations and functions from your 12th standard CBSE mathematics. We'll continue from the exercise 1.2 in your textbook, page number 10. Second problem. Second problem is check the injective and surjective of the following functions. So we have to check whether the following functions are injective, which means one-to-one function. Surjective means we have to check whether they are onto. Right? So they have given the list of functions. So we'll take the first functions. First function f is a function from n to n. F is a function from set of all natural numbers to set of natural numbers given by f of x is defined as x square. F of x is x square. Now we have to check whether this function is injective and surjective. So we'll try to understand the function. So we'll put this arrow diagram. Right? It's a function from n to n. So suppose if I say 1, 2, 3, 4, 5, etc. Then here also 1, 2, 3, 4, 5, 6, 7, 8, etc. Right? So 1 will be mapped to what? F of x is x square. So f of 1 will be 1 square is 1. So 1 will go to 1. 2 will go to 4 because 2 square is 4. And 3 will go to 9. Similarly, you will have 16 and all that, 17, 18, 19, 25, 26, all the natural numbers. So 4 will go to 16, 5 will go to 25. Right? We have to check whether this function is injective and surjective. Now looking at the arrow diagram, it looks like it is one-to-one. We'll try to prove that it is. We'll try to prove if we can prove that it is one-to-one. So, for one-to-one, how do we check? So we'll say let x1 comma x2. We have to take two numbers x1 comma x2 belonging to n. This n, which is the domain. From the domain, we take two elements such that their images are set. Such that f of x1 equal to f of x2, and we should prove x1 equal to x2. If you prove x1 equal to x2, then f becomes 1-to-1. Now what is f of x1? F of x is x square. So f of x1 will be x1 square equal to f of x2 will be x2 square using the definition of the function. So which means you get x1 square is equal to x2 square, which means x1 square minus x2 square equal to 0. Now this can be written as a plus b into a square minus b square, a plus b into a minus b, which means x plus 1 into x1 plus x2 into x1 minus x2 equal to 0, which means x1 plus x2 equal to 0 or x1 minus x2 equal to 0. This shows x1 equal to minus x2 or x1 equal to x2. But x1 equal to minus x2 is not possible because x1 and x2 both are coming from natural number n, which means both are positive. Right? So here when x2 is positive, minus x2 will become negative. But x1 is positive. A positive number cannot be equal to a negative number because both x1 and x2 are from natural number here. Natural numbers are positive numbers 1, 2, 3. So suppose x2 is positive, so minus x2 will be negative. But this x1 is positive. How can a positive will be equal to a negative? So which means x1 equal to minus x2. This case is not possible. Right? So x1 cannot be equal to minus x2 because x1 comma x2, both x1 and x2, they belong to natural number. So therefore we cannot have this case. We can have only this case where x1 equal to x2. Therefore x1 equal to x2. This is the only case that is possible. This case is not possible. This is the only possibility case. So therefore we started with f of x1 equal to f of x2 and we have proved x1 equal to x2. So therefore f is one-to-one function. F is one-to-one. Now we have to check whether f is onto, which means every element here, I should be able to find an element here such that f of this element should be equal to the element that I took from the codomain. Suppose let's observe 2. No element is going to 2, right? No element here because 1 goes to 1, 2 goes to 4, 3 goes to 9, 4 goes to 16, 5 goes to 25, 6 will go to 36. Every number goes to the square of that number. So which means 2 does not have a number. So which element, f of what number will go to 2? F of root 2 will go to 2 because f of root 2 will be root 2 the whole square, which is 2. If I try to find f of root 2, will give me root 2 the whole square, which is 2. So 2 will become the image for root 2, but root 2 is not here. This number root 2, it is not in this set because it has only set of all natural numbers. So therefore it is not onto. So the element f of x which maps to 2, that element also should be in this set. Only then it is called as onto. If not, it is not onto. So here it is not onto. So to prove it is not onto, it is very easy. We will take an element, we will take an example. We will say 2 belongs to n. This n is what? Codomain. Codomain. 2 belongs to n, codomain. But there does not exist x belonging to, there does not exist x belonging to n. Here this n is domain. In the domain there is no element such that f of x should be equal to 2. We cannot, does not exist x. There does not exist x. We cannot find any x in this such that f of x will map to 2. No element will map. Similarly to 3 also, nothing will go to 3 from this. Root 3 will go to 3. The root 3 square is 3, but root 3 is not a natural number. So therefore, even if you take one element and show that this element is not an image of any of the elements here, then that will prove that f is not onto. So therefore, f is not onto. If of such that f of x is equal to 2, therefore conclusion is f is not onto. F is an 1-to-1 function, but it is not an onto function. So we have to talk in terms of injective and surjective, right? So therefore f is, we'll say injective, because in the question they say injective. F is injective, but f is not surjective. So injective means 1-to-1, surjective means onto. So it is not, f is not. Fine. So this is how we prove this. All of you can take the notes. I'll go to the next problem. Now f is a function from, second problem is in second subdivision. Second function is f is a function from z to z. Z is set of all integers to set of all integers, and the function is given by f of x is equal to x square. Z to z. Z to z means set of all integers to set of all integers. F is a function from z to z. Now, so we will try to draw this diagram. Suppose the arrow diagram for this will be like this. So this is z, this is z, z to z. 1, minus 1, 0, 2, minus 2, 3, minus 3, like that it goes. Here you have again 1, minus 1, 0, 2, minus 2, 3, minus 3, 4, minus 4. Fine. 5, minus 5, and it goes on. All integers. Now let's see. Let's try to apply. Let's do some mappings. So 1 goes to where? 1. 1 goes to 1 because 1 square. F of 1 is 1 square, which is 1. So you need not draw this diagram in your exam. But in case if you are having any doubt or you want to understand the function better, then you can draw this diagram as a refer. But it's not required to draw this diagram every time. But I am drawing this just so that you understand how the function mapping is done. So f of minus 1 is minus 1 the whole square. That will also go to 1. 1 will also go to 1, minus will also go to 1. So this clearly shows that f is not 1-to-1 because two elements are having the same image. Therefore, you can immediately say it is not 1-to-1. Clear? Again, similarly, if you take 2 goes to 4, minus 2 also will go to 4. 3 goes to 9, you have 9, minus 9. 3 goes to 9, minus 3 also goes to 9. 0 will go to 0. You see this? Right, now looking at this, what we can conclude f is not 1-to-1. So we will write the proof for f is not 1-to-1. So how do we prove f is not 1-to-1 is, we will show that for two different elements in this set is having the same image. So we'll say f of 1 is 1 square, which is 1. F of minus 1 is also minus 1 the whole square, which is also 1. So therefore f of 1 is also 1, f of minus 1 is also 1. Two elements is having the same image. f of 1 also 1 also goes to 1, minus 1 also goes to 1. Therefore f is not 1 to 1. So therefore we can say therefore not f is not 1 to 1, which means f is not injective. F is not injective because 1 also goes to 1, minus 1 also goes to 1. When two different elements go to the same element, then it is not 1 to 1. It's many to 1. Right? Or you can even say 2. F of 2 is 4, f of minus 2 is also 4. Now 2 and minus 2, two different elements are having the same image, therefore it is not, f is not 1 to 1 or f is not injective. We can prove that way also. We can take any two elements which have the same image. We don't have to write a proof to say that something is not correct. You can just take one example or one element or set of elements which doesn't satisfy the condition for injective. Therefore we can say it is not injective, which is not 1 to 1. Now is it onto? Onto means every element here. We should be able to find an element here. For every element here, every element here should be an image of some element. If you see that when we try to do the mapping, some elements are left out. You see that, like 2, minus 2, 3, minus 3, no element, because for example minus 2, no element will get mapped to minus 2. No element will be mapped to minus 2 because you cannot find any element here such that f of x is minus 2. Your f of x equal to x square means it will always go to either 0 or positive. It will go to either 0 or positive. Right? So all these elements are mapped to only either 0 or positive numbers. 1, 4, 9, like that, 25, 16 and all that. So the negative numbers will not have so negative numbers cannot be image of any numbers here. Or even 2 cannot be an image because for 2 you should have root 2. Root 2 is not here. So for minus 2, no number here will give you minus 2. So we can either say 2 or minus 2. We can say minus 2 belongs to Z, but there does not exist any x belonging to Z, and this Z is the codomain. Minus 2 belongs to Z, that is codomain, right? That is codomain. And x belongs to this C is domain. For an element in domain, we are unable to find an element in for an element in codomain. We are unable to find an element in domain such that f of the element in domain should be equal to the element that we took from codomain. We cannot find. For minus 2, there is no. For minus 2 in codomain, we are not able to find any x in this domain such that f of x should be equal to minus 2. Therefore, it is not onto or not surjective. There does not exist any x belongs to such that f of x equal to minus 2. Therefore, f is not surjective or f is not onto. Okay, this is how we prove this. Right? So now we will go to the next problem, which is the third function. And f is a function from R to R. F is a function from R to R. So f is a function from R to R. R to R is set of all real numbers to set of all real numbers. And the same function f of x is given by x square. F of x equal to x square. F of x equal to x square. Again, we have to check whether f is 1 to 1 and onto, which means injective and surjective or not. So again, if I draw the diagram, so this is R, this is also R. So R will have what? 0, 1, minus 1, and 2, minus 2, root 2, root 3, all that, 1 by 2, minus 1 by 7, all the real numbers, 0, 1, minus 1, 2, 1 by 2, 1 by 3, root 3, minus root 3, minus root 2, 2, minus root 2, all that. Fine. Now what is f of x? If 0 will go to 0, 1 will go to 1 square, that is 1. Minus 1 will also go to 1. 2 will go to 4. Minus 2 will go to 4. Right, so clearly it shows that the root 3 will go to 3. Because what is f of root 3? See, f of root 3 will be root 3 the whole square, which is 3. So root 3 will go to 3. root 2 will go to 2, and minus root 2 also will go to 2. So here itself it's showing that 1 also goes to 1, minus 1 also goes to 1. So it is many to 1. Even 2 goes to 4, minus 2 also goes to 4. Therefore, it is clearly it's not an injective. So we will show that it's not injective. So we will say f of 2 is 4, f of minus 2 is also 4. So two different elements are having the same image 4, which means 2 means 2 square. F of 2 is what? 2 square, 2 square is 4. F of minus 2 means minus 2 the whole square, that is also 4. F of 2 is also 4, we f of x square. F of minus 2 is also 4, therefore f is not injective. F is not an injective function. Right, now we have to check whether f is surjective or not. Now again, if you see this f of x is x square, so this will always go to either 0 or positive. So all the elements, the mapping happens only to 0 or positive numbers. No negative numbers will be mapped. You cannot find any number here such that f of x is minus 1. Because f of x is x square means this x square will be always positive or 0. So if you take any negative numbers here, if I take minus 2 or anything, minus 2, I cannot find a number here such that f of x is minus 2. Because f of x is what? X square. X square cannot be negative because x is the real number. If x is a real number, then x square cannot be negative. It can be either 0 or positive. But R has negative numbers also. So if I take any negative numbers, that negative number cannot be an image of any number here such that f of x will give me minus 2, or f of x will give me minus 3, or f of x will give me minus root 3. So there are these numbers. No negative numbers will have can be an image of any number here. So we'll take one negative number, that is enough. We have infinitely many negative numbers, and none of them have an element here such that f of x is that negative number. So we'll choose. So we'll say again, let minus 2, not mine, let minus 2 belongs to R, which is codomain. From this R, I am taking minus 2. Minus 2 belongs to R, but there does not exist. X, any x belonging to R, here it is domain, such that f of x is equal to minus 2. I cannot get f of x as minus 2. For any x, I cannot get any x. F of x is minus 2. Therefore, that does not. Therefore, f is not surjective. F is not surjective. Clear? So all of you can take the notes. We'll go to the fourth one. Fourth one. We have two more. The fourth sub-problem under 2. That is the fourth one. So f is a function from n to n. F is a function from set of all natural numbers to set of all natural numbers given by f of x equal to x cubed. F of x is equal to x cubed. Now we have to check whether f is injective and surjective. Now we'll try to understand the function here again. It's from natural numbers to natural numbers again. So if I take here, so n, so 1, 2, 3, 4, 5, 6, 7, 8, many numbers. 1, 2, 3, 4, 5, 6, 7, 8, So 1 will go to 1. 2 means 2 will go to 2 cube. 2 cube is 8. 2 will go to 8. 3 will go to 27. 3 will go to the number 27. 4 will go to 4 cube, which is 64. So that's how the mapping is. 4 will go to 64. 5 will go to 125. 6 will go to 216. So that's how the mapping is. So this somehow says that it is looks like it is 1 to 1. Right? So we will show that it's 1 to 1. So we'll say let two elements x1, x2. So when you draw the arrow diagram and if you feel that it is becoming many to 1, right? Two elements are going to the same two different elements are having the same image, then you can immediately say that the two elements have the same image, therefore f is not injective. Like this we can prove. So, but here we see that everything is going to unique. Like 4 also will have some. 4 will go to 64. 4, 5, suppose dot 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 dot. 4 will go to 64. 5 will go to 125. So every element. So this looks like a dot 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 dot, like a one-to-one function, right? So based on that, once you feel that it is one-to-one, then we'll try to write accordingly. Write the proof that it is one-to-one. Now x1 comma x2 belonging to n, that is domain. From domain we are taking two numbers x1 x2 such that f of x1 equal to f of x2. Now what is f of x1? F of x is x cube, means f of x1 will become x1 cube equal to f of x2 means x2 cube. F of, right? So now we'll try to solve this. x1 cube minus x2 cube equal to 0. Now x1 cube minus x2 cube is a cube minus b cube. Formula is a minus b into a square plus ab x1 x2 plus b square. B square is x2 square equal to 0. Now this tells us either x1 minus x2 equal to 0, either this is equal to 0 or this one, x1 square plus x1 x2 plus x2 square equal to 0. Now here you get x1 equal to x2, this x2 goes here, or here we have to solve x1 in terms of x2. We find the value of x1 equal to in terms of x2. So this is a quadratic equation, right? Suppose if we take this as a quadratic equation in x1 square, right, our a will be what? A will be coefficient of x1 square, which is 1. Our b will be x2. Our c will be x2 square. If you compare this with our quadratic equation, ax square plus bx plus c. Here you take your x as x1, right? B x1. So in the place of b you have x2, in the place of c you have x2 square. Now let's try to find what is b square minus 4ac. We'll try to see whether it has real roots. So b square minus 4ac is what? B square is x2 square minus 4 into a is 1 into c is x2 square. So that will give you minus 3x2 square. So which is negative. Minus 3 is negative, x2 square is always positive, minus 3 x2 square is always negative. So we got b square minus 4ac is less than 0, therefore no real roots. So therefore this will not have any roots. You cannot say x1 equal to something of x2. So therefore no real roots, which means we need to solve this and find what is x1 equal to what. X1 you will get in terms of some x2. That is not required because your b square minus 4ac is negative here. So therefore the only case that is possible is this, which means x1 equal to x2. So we started with f of x1 equal to f of x2 and we got x1 equal to x2. Therefore f is injective. It's an one-to-one function. Now is it onto? Is it onto? Now clearly if you see, no element is going to 3 here. 3 goes to 27. Then no element goes to 2 also here. So 2 does not have an element here such that f of that element is 2. So therefore f is not onto, right? So how do we prove that? So to prove for f is not onto is, we'll take an element here. We can take 2 or 3 or 4 also, it doesn't matter. We'll say suppose 2 belongs to n, which is codomain. We are taking an element from codomain, but that does not exist any x belonging to n domain, in bracket domain, such that my f of x should be equal to 2. We cannot find any x such that f of x gives me 2. If I put some value of x, I should get 2 here. X cube should be equal to 2. And that x should be a natural number. I have to put a natural number here such that the cube of the natural number should be equal to 2. That's not possible. Cube of no natural number will give me 2. Cube of no natural number will give you 3, 4 or even 5 or 6 or 7. Only we can get the next number as 8. So these numbers 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, all these don't have any x here such that they cannot be image of any element in this set. Therefore, it is not onto. Even if you take one element, that is enough to say that it is not onto. Therefore, F is not surjective. Not surjective. F is not surjective. Here F is injective. F is injective, but it's not surjective. Right. Now let's do the fifth one. Right. All of you can take the notes. I'm going to change the same problem to the fifth one because it's similar to this. Now, how do we check for the fifth one? Where is this? The fifth problem is under 2, fifth subdivision is f is a function from z to z, z to z, and the function is f of x is equal to x square. We have to check whether it is injective and surjective. Again, if you try to understand this function again, it's same thing. When we try to put, suppose if I have z and z, so z to z, it is 0, 1, minus 1, 2, minus 2, like that it goes on. Here also 0, 1, minus 1, 2, minus 2, it goes on. Now f of 0 is 0 cube. 0 will go to 0, 1 will go to 1, minus 1 will go to minus 1, 2 will go to 2, or 2 cube, which is 8, 2 will go to 8, minus 2 will go to minus 8, right? Well, minus 2 cube is minus 8. So that's how the function is. But it looks like from the arrow diagram it is 1 to 1. Right? We'll try to prove that it is 1 to 1. Now x1, x2 belong to z domain. So that f of x1 equals same thing you will have to do. Finally, you'll get fs. And here also this condition, no real roots. Therefore, f is injective. So we started with f of x1 equal to f of x2, the same set of argument that we did for the previous problem. That will show that f is injective, because we started with f of x1 equal to f of x2, we proved x1 equal to x2. This case will not come because it does not have real roots. So here you cannot find x1 and x2 such that this condition is satisfied. So this will never become 0. Only this has to become 0, which means x1 equal to x2, f is injective. So similarly for onto, again if you see 2, there is no element here where it is getting mapped to 2. Even minus 2, there is no element here which goes to minus 2, which is mapped to minus 2. So which means minus 2 cannot be an image of any element in this, or 2 cannot be an image of any element in this. Therefore, it is not onto, which means not surjective. So we can say 2 belongs to, here we should say z, because our set is set of all integers, but there is not any element belonging to z such that f of x is equal to 2. Therefore, f is not surjective. So in this case also f is injective, but f is not surjective when f of x is equal to x cube and it is from z to z, set of all integers to set of all integers. Right? So all of you can pause the video and take the notes, and I will stop here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.